Hey guys, I'm Pedro Hayes, and today we're starting the third class of calculus on my blackboard. Um, just before the class, I like to tell you guys why I didn't post videos for 2 weeks. It is because I was studying for the August SAT, but now I'm back and I will continue release videos normally. So let's start. When we think about derivatives, we need to think about a linear function. And what is a linear function? Linear functions are functions that are defined as y equals to mx plus b or ax plus b. But let's say m. M, it is the slope of a function. So let's draw one over here. Let's actually write one. F of x equals to 2x. Okay? Now let's plot the points. When x equals to 1, let me just do some lines here. 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. This is okay. So when x is equals to 1, the y is equals to 2. When x equals to 2, y is equals to 4. When x equals to 3, y is equals to 6. So it is over here. Those 3 points are good to have a look. Now when y is equals to minus 1, when x equals to minus 1, y is equals to minus 2. When x equals to minus 2, y is equals to minus 4. And that's already great for drawing a line. So let's draw a line that connects everything here. Okay. I'm going to draw on top of it these points. Okay. And so let's calculate the slope of this function. Just by looking here, we can say the slope is equals to 2. But there is a calculation that you can do to get to this 2. This is the y2 minus y1 divided by x2 minus x1. On this case, let's use this point over here and this point over here. So y2 is equal to 4. So 4 minus y1, that is 2, divided by x2, that is 2, minus x1, that is 1. Let's write m here. Then this is equal to 2 divided by 1, that is equals to 2. That is the slope of the side. But what does this linear function stuff has to do with derivatives? So basically, on the derivatives, you are going to find the slope of functions that aren't linear, like x squared, for example. And yeah, basically, you need to think derivatives as a factory of instant rate of change slopes. Okay, so let me erase this. Now we have that f of x is equals to x squared. So let's plot some points. F of 1 is the same thing as f of minus 1 is equals to 1 squared, that is equals to 1. So let's draw the points. It's 1 here and 1 here. Now f of 2, that is the same thing of f of minus 2, is equals to 2 squared, that is equals to 4. So 2 and 1, 2, 3, 4 here. And oopsie. And here. We can already draw this line. Let's also write f of 0 here. F of 0 is equal to 0 squared. That is equal to 0. That is a point over here. So drawing the graph, let me use a different color here. It is going to look like this. Okay, not perfect, but good. So yeah, I want to find the slope between these points. Let's use, for example, x equals to 1 and x equals to 2 here. Let me highlight this part of the function. Okay, I want to find the slope at this point. To do this, I have to write do a line that goes through these points. Okay, a linear function. But this isn't a instant rate of change, if you think, because it's going through two different points and it's not tangent to a specific point. Okay, but let's do this. To find the slope, I need to write y2 minus y1 divided by x2 minus x1. In this case, y2 is equal to 4 minus 1 divided by x2, that is 2, and x1, that is 1. Okay, this is 3 divided by 1, that is equal to 3. So basically, this line over here, the slope is equal to 3, the rate of change of this line. But now we're using content from the previous classes, the limit classes. Well, how can we use this on here? So let's try only to erase 0. Okay, so we want to make this difference, the difference between these 2 points, really close to each other, almost nearing 0. So we're basically going to write a point that is just above this, but with a difference that we call h, that is almost 0. In this case, use limits of h tending to be 0. Okay, so let's forget about the numbers. Let's just define this as x. So this first value here is x. It's x. Oh, it's kind of big. Let me try. Yeah, x. And here I have a point that is almost the same number, but a little bit bigger, that we call x plus h. Okay? And here in the answer, we have f of x, and here in pink, we have f of x plus h. Now let's substitute this on the function, on the calculator gave before, to define slope. That is y2 minus y1 divided by x2 minus x1. So y2 on this case is going to be f of x plus h. So f of x plus h minus f of x, that is our y1, divided by the x2, that is x plus h, x plus h minus x. We can cut this x with this x, and we're left with limit of h tending to be 0 of f of, this line is not good, here's better, of f of x plus h minus f of x divided by h. And with this function over here, we'll find a line that is tangent to this point, that goes like this, okay? It only touches one time the point that you want to find the instant rate of change. This is why I told you guys before, you need to think that a derivative is a factory of instant rate of changes. Okay, so this is class 3, and the next class I'm going to do an example using this limit function to find the derivative. Thank you all you guys for watching, and see you on the next one. Bye.